Good morning, year 13s. Thanks for coming along, guys. I'm just getting my laptop all set up. Hi, Winkit. Thanks for saying hi to the chat. It's nice to see that you're there. So today, guys, we're going to be focusing on A2 nomenclature, so A2 naming, and we're going to be focusing on the aliphatic side. So just to tell you that the word aliphatic, yeah, there are two, you can kind of subcategorize organic. So A2 naming, and we're going to be focusing on the aliphatic. There we go. Let's get rid of that now that I know that that's all working. Yeah, so you can subdivide organic chemistry into aliphatics and aromatics. And aromatic, of course, is anything that's got benzene in it. And I'm going to be doing aromatic nomenclature completely separate from aliphatic. Aliphatic is any hydrocarbon, and you shouldn't even really call them hydrocarbons, if I'm honest, because they can include nitrogen and oxygen in them, but it's anything that does not contain a benzene ring. So we're going to be focusing on that for the A2 specification today. Let's crack on. And last lesson, share screen. Last lesson, I think is that Xavier? I think that was Julian, right? Don't know. Anyway, cool. Right, let's crack on. Flatten my tablet. So this is what we did last lesson. So last lesson, we introduced all of the families for A2. Now what we're going to do is look at the naming of each one of them. So, and all I really wanted to do with this lesson was to just introduce you to the families and the structures you're going to see and get you to recognize them. Now, I do want to mention this family name, yeah, and I'm going to, that comes under what's called classification, and I'll do that a little bit today as well. So we kind of covered classification last lesson, but okay, let's go for a new sheet. Okay, so this is A2 organic naming. A2, oh, that's not what I wanted. I want it to be up here. Let's try that again. There we go. A2 organic nomenclature. And this is lesson 1. This is L1. And this is aliphatic. Aliphatic naming. Anything but benzene. No. Now, the learning objectives I put onto the YouTube video. So, learning objectives for today, I'll see if I can copy and paste them. It'll just save me a little bit of time, I reckon. If I can track it down. Let's make that keyboard vanish. Let's see if I can track down my learning objectives. Edit. There they are. I'm going to copy and paste those. Saves me able to type it on my silly keyboard. Oh, that's interesting. That means I know it's... Oh, yeah, it's all good. It's all good. There we go. And la past. There we go. So know your A2 families. Yeah. Know one for each family and then name others using your go-to molecule. Okay, guys. So the first one we came across, the first family we mentioned, I'm going to switch to pencil. I'm going to zoom. I'm going to put my little fan on. Oh, put it on low. There we go. When my laptop gets hot, it tends to freak out. So, okay, the first family we talked about were the acyl chloride family. Now, acyl chlorides technically come under what's called the carboxylic acid derivatives. And so what I'm going to do is we're going to put, there's another name as well, they're called acid chlorides commonly called acid chlorides. And I gave you this structure. I said R bond C, double bond O, bond Cl. So this is the acid chloride family. Now, this is the displayed structure of the functional group. So there's the functional group here. I'm going to put this into a written expression as well. And I'd like to call this cockle. Yeah. If you ever see cockle, that's an acyl chloride. Okay, so this family is a wicked family, very reactive, bonkers reactive. And so what we need now to do is we now need to name one, and we need our go-to guy. And our go-to guy, the one that you're going to see most commonly on any A2 paper, is this guy. So this one, and then I'm going to translate structural underneath. Cockle. There we go. So this here is F, and just to explain to you where the name comes from. So F, I ought to color code this. But then, yeah, so color code this. So 2 carbons, F. Oh, I've got a message just to check. No, I'm sure it'll be fine. Having 2 screens, it does it does make things a little bit more challenging. Lol. Yeah, so there's the F. Next one. There's the an, F-an, because it's a single bond. But now we see this family here. And I just need to switch to that kind of color. Purple, but it's like that one there. And this is O-Acyl chloride. Ethanoyl chloride. There we go. Okay, so I want to give you another one. So this is your go-to guy. You need to learn this, guys. Learn this one. What I'm now going to do is I'm going to rope in the dis and tris of the family throughout this process. So let's now do another one. Let's do another one. So let's try this one. So I'm going to put this out on the chat. Can I ask anybody on the chat, please, to give me the name of this guy? And you realize what you're constantly doing is using your knowledge of the one you learn, cockle, yet to give the next name of the next molecule. And you realize this isn't particularly complicated. It gets a bit more tricky with the dis, and we'll see that in a second. So who's going to be the first one on the chat to name this guy? Just having a cup of coffee, by the way, guys. Oh, it's really hot. It's really hot. Ouch. Ah, it's really hot. Propanol chloride. Thank you, Winkett. Thank you, Tansy. So we've got propan Oil. That's the one. You realize you use your understanding of the one that you learn. This is I like to call your go-to guy. Yeah, if you ever get stuck, you always go back to your go-to guy. Yep, propanol chloride. Well done. Let's make this more difficult. Let's make this more difficult. I quite like to swing it. That's absolutely fine. Could have swung the CL around, but I don't want to leave it like that. There we go. What about this guy? Now, the reason why I mentioned this one is because Edexcel have done it on multiple choice in the past, but it was on multiple choice, so it gave you a little bit of leeway on this in terms of the level of difficulty. So this is still a probe. It's still a probe. It's still an an. But this time, it's a di. So if we ever have, because we've got two suffixes, it's going to become dioyl dichloride. I know it's horrible that you need the two di's. It's a really bizarre example, but you just do. So this is, but the clever bit is the E goes back in. It's just a reminder, whenever you have a di suffix, because once again, in Edexcel, they tend to do this quite regularly. So propane dioyl dichloride. I know, right? Go figure. Dioyl dichloride. So, and the E there is the tricky bit. Now, just to tell you, by the way, that some students often say, why do you need the two di's? Why can't you just go dioyl chloride? Well, in some cases that's actually allowed. But the clever thing was, it's not really the correct name. The correct name requires the dioyl dichloride. That is the correct name in this regard. Yeah, because you're stating that there's two chlorines on it as well, even though the family name of dioyl chloride works. Like, I get that. Now, the clever thing is they didn't give that as an option. They gave that as your option. Yeah, and they gave all kinds of other funky things at that point as well. But like I said, it was on a multiple choice, so it's nice to cover. So let's do another one. Let's do something which is a bit more challenging. Let's add in some branches. Why not? Let's add in some branches. Now, Edexcel, like all other exam boards, they're all about their tricks. And that one there is a trap. So on the chat, please, impress me, year 13s. Impress me. Now, while you're having a go at naming that one, I'm going to start moving on to the next one. So we've done acyl chlorides. Now, each one of these families I'm then going to sub-teach as well. I'm just focusing today on naming. That's all I'm focusing, just on nomenclature. That's all I'm doing. Okay, so the next family, I'm going to do this the same list as we had last time. So we're now going to the acid anhydrides. Now, can I just point out, by the way, that the acid anhydride family is not strictly on the Edexcel specification, but they've done it. Yeah, they've done it in both multiple choice and they've done it in long answer, which I think was super cheeky. Did not enjoy that one bit. 1,1-dimethyl butanoyl chloride. Winkit. So close, Winkit. Julian, so close. Both of you are incorrect so far. Can you find the errors in your naming? Both of you have made a mistake, but different mistakes. What a lovely set of answers. Two different answers. So Winkit thinks his methyl is incorrect. No, it is a methyl. Julian's mistake was the methyl. Yours was the numbers, Winkit. The reason being, it's a great trap, right? Well done for neither of you two fell into the trap of the longest chain, which I'm very happy about. It's a 4-chain, so it's based on a but. The next thing is, as soon as you see the family, it's, okay. So this is, and they're all single bonds. So this is butanoyl chloride. That is correct. You got that name correct. Dixon's gone mad. Nobody gave me the correct name. Isn't that fascinating? And then on carbon number 2, we've got 2 methyl branches. Yeah, so typo. It's not a trimethyl though. That's the thing. It's a dimethyl. It's a really good effort, guys. This is a 2,2-dimethyl. If I take all your names and put them together, then we'll get the right one. So this one is 2,2, final name, put them all together. 2,2-dimethyl. Julian said ethyl. Dimethyl, which is where he then corrected it with the methyl. Butanoyl chloride. Now, isn't that fascinating? I've got 4 people in the class. And out of 3 people who contributed, Tenzi just ignored me. Thanks, Tenzi. Cheers, dude. Nobody got that mark. Scary, right? It takes practice. And, even I make mistakes at times. But the clever thing there is recognizing where you're counting from. The OI will always be number 1. Recognizing that the longest chain, that this is not a branch. Yeah, that was the trap in reality. But clever question. Since nobody got it right, should we have another go? Let's do another one. Let's do another one. Yeah, why not? A classic Edexcel. Classic. There we go. Impress me, year 13. Give me the name. Take your time. Break it into its pieces. That's the important bit. Break it into its pieces. You can pause the video there, guys. I'll move on to the next family. Right, the next family are the acid anhydrides. Acid anhydrides. Like I said, not strictly an Edexcel family, but they've done it, which really annoys me, actually. I feel like if they want to choose families to name, they shouldn't be asking you ones that aren't specifically on the specification. And I just don't like that they've done it. It means that I essentially have to do something I don't really want to do, but there is value in doing it anyway. I will also teach you the acid anhydrides and the mechanism as well, because that's been up on Edexcel as well. One of the things I might ask one of you guys to do is to trawl the textbook and see if any of these come up anywhere. I wonder if you've got a digital copy of the textbook that you can do a PDF search for. That would be amazing for acid anhydride. Okay, so the acid anhydride, your go-to guy is this guy. Now, I'm going to draw 2 pictures. I'm going to draw it straight, and then I'm going to draw it in the spaceship fashion. So this is the first guy. There we go. Let's then draw it the way I like to see it. I'll even give you a third one as well. These are all the same molecule. And you have to be able to kind of recognize that when they do it. It's rather mean, to be fair. There we go. Hey, got some answers coming out there. Let's have a look. Got Julian. Julian's definitely lost it. Ivan says, nice. Hi, Ivan. Good to see you, dude. How's the research going, Ivan, on all the interview questions for your Chem Eng? How are they getting on? It's been fun to spend time with you this weekend in order doing some interview prep. It's been really nice. Right, let's run it. Let's see how many people get it right. Longest chain is a butte still, so it's still a butte. It's still an an. Family is an Oil chloride. No number required because it's always on the end. It is now number 1. You see, so easy. There we go. I've chosen to put a bend in it. I don't know why I chose to put a bend in it. Don't know why. I could have done it lengthwise. It's totally okay for me to do that. There you go. That actually works as well. It's actually easier probably to understand as well. So attachments, I've got a trimethyl. So I've got a 2,3,3 trimethyl. But then I also have a 2-chloro. Then I need to do it alphabetically. C comes before M, you ignore the tri. Yeah, so that's going to become final answer 2-chloro dash 2,3,3 trimethyl butan Oil chloride. Nice. Let's see how many people get it right. So Julian forgot the an. Yeah, he put butyl chloride or butyl. You've missed the an. Otherwise, it was good. Winkit, well done. Spot on. Absolutely correct. Tenzi, spot on. Absolutely correct. Well done. Dixon. No, Dixon, your numbers are missing and they're in the wrong place. Yeah, watch out for that. Going well. More confident now. Good job, Ivan. Proud of you. Doing really well. Good job. It'll be worth all the hard work, I promise. Promise. Right. Let's move on to the next family. So this is our acid anhydrides. So acid anhydrides is a lovely family because the name of the family tells you how to name it. Yeah, the word acid, yeah, is telling you the acid it was made from. So if I zoom in here, this is the carboxylic acid. Carboxylic acid it was made from. Made from. And then the anhydride means without hydrogen. Now that has a bit of a confusing status in it anyway, because you lose water when they're formed. So this guy here, if you cut it in half, what you realize is it's 2 methanoic acids. Yeah? And they've been joined together. So we've got 2 carbons on either, 1 carbon on either side of the oxygen. So this one here is methanoic. Methanoic, we'll try and zoom in a bit. Methanoic anhydride. The reason why, let me show you. I prefer using my this diagram here. I prefer using my spaceship one. Just to show you why. Because here's methanoic acid. And here's methanoic anhydride. What you realize is both sections, if you were to split it there, you realize that it's a methanoic acid molecule, but without the hydrogen. Yeah? If you were to split it here and look at this side, yeah, sorry, to split it there and look at it, it's still, even though in reality, if you were to take this and make it from its molecules, and it's nice to mention this, it's just a bit of an anhydride theory, yeah, if you were to take methanoic acid, if you're going to take methanoic acid, and you have to take 2 of them, and you were to push them together to form an anhydride, what you actually realize is you're losing water. There's the H2O. That breaks away, and a bond forms across there, which is your anhydride. There you go. So the great thing is you can actually reverse this. If you take an anhydride and you add water, it'll turn back into 2 carboxylic acids. That's actually a nota bene. Can you add that as your nota bene, please, which means learn this? Yeah. addition, adding water, by the way, it's called hydrolysis, adding water to acid anhydrides, or I'm actually going to say acid anhydrides, adding water to acid anhydrides, you get carboxylic acids back. Silic acid back. You'll need a mechanism for that as well for Edexcel. I think that was the one they actually did in the exam, even though anhydrides aren't specifically on the specification. Stupid. Okay, so let's now now that we've got methanoic anhydride, let's do some questions. Okay, so let's try this one. Yeah, let's do this one. Oops. On the chat, please name it. The next one, I'm going to get you to write down your name there. The next one is this one. An unsymmetrical anhydride. That might freak you out. There we go. Try that one out for size. Going to give you one more. Oh no, I'll just leave it at those two. They won't go beyond that. Ethanoic anhydride, thank you, Winkit. This is ethanoic anhydride. It was made from ethanoic acid. Nice and easy. Split it any point and go, who was that guy again? Oh yeah, that's ethanoic acid. Thanks, guys. What about the next one? Bit more tricky, huh? An unsymmetrical anhydride. Ooh, it's exciting. This is going to be much more entertaining to see how people get on with that one. Methanoic anhydride is absolutely spot on, Winky. Well done. We've made it from two acids. We've made it from methanoic, and we've also made it from ethanoic. We've made it from two of them. So I need to then do them alphabetically. Well done, Winkit, for doing so. Ethanoic goes first because of the E. Ethanoic, methanoic, anhydride. Well done, Winkit. Great job. An unsymmetrical anhydride. So nice and easy, these ones. They are tricky ones to recognize. In terms of formulae wise, it's nice to show you, I'm showing you displayed here. Here's what it looks like from a formulae perspective. Here's the ethanoic anhydride as a formula. CH3CO brackets 2O. Isn't that disgusting? Really horrible. Yeah, this one, we can do CH. No, we wouldn't really. The H would be on the other side. O. Now, the thing is, what you're tempted to do is that. Yeah, you can do that. That actually works out annoyingly. Horrible, right? Really grim. Don't like it. You could also say that the methanoic, they'll give you all kinds of funky stuff to do this one. You could also have this one as being so if you take the longest chain, which is ethanoic, which is CH3CO, what you can then do is add the other guy on as a branch, and that becomes COH. Oh no, HCO in that case. You can't do the H next to the O because it looks like an alcohol. That's really nasty, that. Not nice at all. What they're telling you is that that must be a branch. Oh, the problem is if you do that, it says branch off the C. Oh, maybe that's not entirely right, because the problem is bracket means branch, bracket branch. I'll check on that. That one I'm going to check. But certainly the top one's correct. It's very unusual to see well, I've seen that in an exam. Never seen that one though. I've never seen, have I ever seen yes, I've seen one in 15 years, one unsymmetrical acid anhydride being named, just one. So they're very rare, but it's nice to do them. Right, let's do the next family. Next family after anhydrides, amines. Right, now amines will be reinforced, guys. when I teach you amines. It's going to entirely separate. Each of these is going to get a lesson anyway. So amines. Now we've got a little bit of understanding from amines from AS, but only a very basic perspective. So what we now get is, the problem is we now get primary, secondary, and tertiary and quaternary. So we've got, oh, that's telling me I've got 10 minutes left. I'll have to end this at the amines. So we've got primary, secondary, tertiary, and quaternary ammonium salts. Let's draw each one out. Nitrogen. I'm going to keep it as simple as possible. CH3. So there's two names now. Methylamine, my name, the original name. The family has now since been renamed, but they still allow both, especially at Acyl. Methanamine, they also allow that one now. You can choose which one you prefer. Secondary, the nitrogen now has two R groups. I'm going to do it this way. There we go. Dimethylamine. Dimethylamine. You can, now at this point, that's an interesting one, isn't it? The reason why I don't really like, dimethylamine says two branches off the end, because methyl means branch. But now they're saying methanamine. So their new version of this, I would speculate on it being called methyl methanamine. N-methyl to boot. I don't like it. N-methyl methanamine. I need to check that one. You can't have dimethanamine. It's not, you can't do that. The problem is when they change families, it adds in a whole load of rules, which I really don't appreciate. So let's do that as methyl methanamine. Methyl methanamine. Otherwise known as dimethylamine. But there we go. So it is actually giving you the IUPAC name as being exactly what I would have predicted it to be. N-methyl methanamine. The reason why, structure naming. IUPAC. There you go. Look at that. That's actually the modern IUPAC name. Computed by LexiChem, PubChem 2019. Isn't that a nightmare? I don't like it. That's the new name. It's exactly what I thought. The reason being is, what you're saying is the methan is the main chain. Because in the old days, because it was methylamine, they're saying that the most important structure is the N, which it is, which is why there's primary, secondary, and tertiary. Yeah, but then, and in dimethylamine, you're saying that there's no point in having a long chain because they're both the same length. That's a better name in my eyes. But then the problem is, if you're going to go down the brand new IPAC rule, you then need to actually say N-methyl methanamine, because the methyl and the methan is different. It's a nightmare. Let's go for a tertiary. Names are getting longer, so I'm going to move them over. So let's go for N, and let's do all kinds of funky stuff now. Let's do this. Right, this is now a tertiary. Yeah? And it's tertiary, if you're wondering why. Primary is because the nitrogen has one R group. Yeah. Secondary is because the N has two R groups. Yeah, two. Tertiary is because the N now has three R groups. So we've now got this, this is clever, because now we have a longest chain. So now I'd actually prefer to switch to the now modern IUPAC version, because this is based on ethanamine. And then I'd say, and by the way, the N is telling you where the branch is. It's acting like a number. So this becomes N dimethyl. If you want to go old school, dimethyl ethylamine. It's the original name. Now, of course, with the modern, they're saying that you can now switch this to being NN dimethyl ethanamine. And that's fine. I actually don't mind that. I prefer mine because, of course, I learned it as mine. That's my old name. Makes me very upset that they deleted it. Very sad. Very sad. So anyway, great effort, but it's nice to understand where these numbers, this N here and this N here, is because the methyls are attached to the N. Same with this one. Yeah, you're telling their location. If you don't give a location, it means it's on the main chain. I'll give you another one. Yeah, let's do another one. We can even make this a quaternary. Oh, maybe not. Let's let's stick with a tertiary here. Let's do that one. Add in all my letters. Mixture of displayed and structural. That literally makes me want to vomit that picture. I hate that at Excel do it. Should never allow it. It's not a good picture. That it should be complete. If you want to do displayed, do displayed and do it properly. It honestly, God, makes my skin crawl. I don't like it. And it's just, there is no rule to whether or not, oh, I'm going to accept it for this one or not accept it. I just don't like it. Just, if they ask you for displayed, you must do this. You've got to show them all. Right. So if we're going to name this, number 1, it's an amine, and that's my longest chain. This is propanamine. Propanamine, modern name. If it was my old name, it would be Acyl, propylamine. That's the old name. Next, we've got 3 branches. Now, what we could do, and they're all the same as well, so it's a trimethyl, but we need to give their locations, which is tricky, because we're going to have, and which one goes first, the number or the letter? I'm going to say the letter goes first. NN2 trimethyl. We'll type that into Google, so here we go. NN2 trimethyl, because what you're saying is 2 of the methyls are on the nitrogen, and 1 of them is on the 2nd carbon on the longest chain. Let's Google it. I've never seen one that would do that, but it's always fun to play. Love playing with naming. It's always entertaining. So N, comma, nuts. N, oh dear, N, comma, 2. Oh, it's there. Oh no, that's slightly different from what I had. Let's get rid of the 2. Images, let's go for images. Why are they deciding to? There we go. There's one. There it is. NN2 trimethyl 2. Oh no. Okay, they're saying that I actually have to provide another number of where the amine joins on. They're saying that because the problem is that this section otherwise here could be joined here. That's what they're saying. Yeah, okay, that's reasonable. Propan 1, I actually would put the number in a different place. I'd put it there. Let's see. Fascinating. I don't want an amide. I haven't got there yet. Amine. There we go. So I did need the, hang on a sec. Find it. Isn't that fascinating? No one's actually got that one anywhere. Rand, isn't that fun? I wonder if it's because it's not possible to make. Possible, I guess. Or if people are going to ask me why that number goes in that particular location, I don't think that number, there you go. There it is. We had the 1 though. Yeah. Isn't that interesting? Loads of really funky different names. Isn't that horrible? Stupid. Anyway, so more with that. Oh my goodness. Oh my goodness. That's funny. Yeah, you don't want to even get lost in that bit. I'm happy to add in that one. I'm happy to make that adaptation. It's fine. Anyway, it's the end of the lesson, guys. I'm going to leave you be at this point. So we've done some naming. We'll finish amines off next time. We'll do part 2. I'll end my lesson there. If I can find my SteamYard thing. There it is. Bring it back to me. Sorry, guys, I've gone over by, well, I'm actually dead on the money. I'll leave you guys be. Have a nice rest of your day. I'll see you next time for nomenclature part 2. Bye, guys.